We're here to talk about the semantic engine that we have developed. We call it Control. And besides this presentation, we are also showcasing the engine. We have a booth at 302. So whatever we talk about here, you can go and actually take a look and see it yourself. Please drop by if you like what you hear. All right, so the Control semantic engine. It's really an engine in the sense that it's not a final product of any kind. It's not a service. It's an engine with an API to do the following. You can use Control to extract key topics from any document. And later on, we will see what we mean by topics. They are not phrases. They are not words. They are semantic objects that we will discuss. You can use the Control semantic engine to do entity extraction. So the engine identifies different kinds of entities: people, products, names, organizations, brands. The engine also generates a summary of the text, and you can also see that live. And finally, if you can do all this stuff, then you can definitely relate documents by their content and their meaning. And thus you can do retrieval, topic-based retrieval. So that's what the Control engine does. Control is definitely not a natural language processing or natural language understanding system. So Control is not a question answering system. It is a semantic engine that does the above. So a little bit about entity extraction and Control. By entity extraction, we mean extracting names of things, identifying them. But this is not as trivial as it sounds, because names are also ambiguous. So for example, Ford in this phrase, in this snippet, is a person. Ford here is a car. And Ford here is a place. It's a county somewhere. And so names, like other nouns, are also ambiguous, and you have to infer the right meaning. Now, when we say semantics, and lately everyone is saying semantics, and obviously this is the appropriate place to throw the word semantics. But outside this conference, and I have to say even in this conference, the word semantics is really being thrown around, sometimes needlessly. And it's probably one of the most abused words lately, next to ontology. So what do we mean by semantics? Semantics is an old field of study. I mean, Plato did semantics. And really, semantics in the absolute sense is the study of language, the meaning in languages. There's something even bigger than semantics called pragmatics, but semantics itself is a huge subject. And understanding or comprehending a piece of text, which really is the business of natural language understanding, is not what we're doing here. So we're going against the trend. We're saying we're using semantics in a very conservative sense. We're not doing natural language understanding, at least not in Control. Which means when you hear the word semantics, you should keep that in mind. So, but then how is Control a semantic engine? Because we are saying Control is a semantic engine. Control is a semantic engine in this sense. In Control, we go beyond words. We definitely go to meanings. That's where the semantics come in. So we go from words to concepts. And from concepts, we go to compound concepts, which we call topics. So for us, topics are, if you want, complex semantic objects. They are compound concepts. So for example, information retrieval is a concept, is a topic, which is a compound concept made from information and retrieval. We'll go through an example shortly. Control is a semantic engine also in the sense that we analyze these topics to discover the key topics in a document. Because knowing what topics you have is one thing, but then what are the key topics? What is the document about? And Control is a semantic engine also in the sense that it relates to documents by content and topic, relevancy, and meaning, regardless of the words that are being used in either document. So that's how Control is a semantic engine. It has nothing to do with the semantic field of natural language understanding. Well, not nothing, but it's definitely not doing natural language understanding. This is how it is a semantic engine, which is not trivial, but this is what it does. So what do we mean by we go from words to concepts. Words have multiple meanings. Meanings have multiple labels that are words. So the relationship between words and meanings is many to many. And this is a difficult problem. Computational linguists and NLP people have worked on it for many years. It goes under the label word sense disambiguation or lexical disambiguation. And it's a challenging problem. I'll give you an example. If we say John had a blast at Dave's birthday party, then party and blast have one meaning. Blast is different here, obviously. A powerful blast ripped through several buildings in the center of Baghdad. Blast now is a different thing. And party now is different from party in A. John, what does it say? Attended the annual gathering of the Social Democratic Party. So party now all of a sudden is a political organization. That's what word sense disambiguation is all about. And it's a very challenging problem. That's what we do in control. We go from words to concepts. We discover the right meaning in the context. And we have a very accurate algorithm that is, we believe, one of the highest. Then we go from primitive concepts to what we call topics or compound concepts. And the point here is this. If I have a phrase like this, a nominal phrase like text processing software, the first challenge is to figure out the right meaning of each of these, going from words to concepts. So text 2 is probably the second meaning of text. Processing 2 is also the second meaning of processing, which has probably 7 or 8 meanings. And software, we figured out the actual meaning. So now we have concepts. Now we have to make a topic, a compound concept, out of these 3 concepts. So now I have a topic, a semantic object called text processing software. On the other hand, I might have information retrieval system. Again, I figure out the right meaning of information, the right meaning of retrieval, and the right meaning of system. And now I have a topic, a compound concept called information retrieval system. Now I can match these 2 topics that are obviously relevant. If you don't go through these levels, these 2 phrases are not connected in any way. Okay, so we have topics now, and we can match topics conceptually. And then we have to analyze them to discover the key topics in the document. And now we know what the document is about. And topics now can be ranked in order of importance, so I know that this document is mostly about this, then it's somewhat about this, and it's also about this. As an example, this is a document that has many topics. Actually, many systems deal with them as phrases. They don't even go to topics. But let's say they do topics. This is a phrase, the first one, Google's Android market, that is definitely a key topic in this document. This is another phrase, text messages. There are many other phrases here. AT&T customers. There are many nominals. Some of them are key topics in this document. Some of them are not. And obviously, we have many words that we just use to glue together an English text to make a linguistic object. So many words are not irrelevant, but they are not representative of what the document is about. So in summary, this is what we do in control. We go from words to concepts. And that's a challenging process on its own. You have to discover the meaning of the word in the context. Then we combine concepts into compound concepts. We call them topics. And then we analyze these topics to discover the key topics. And now we know what the document is about. So how is it different from others? Besides the fact that we do all these, that we haven't seen anywhere. Well, doing deep semantic analysis has always been a difficult thing. And so one of the difficulties with many systems have been, was performance. And that's not an issue in our system. Again, if you visit us in the booth, you can see live. You put a document and you process it, and you see that all of this stuff is happening very fast on a laptop. So performance is not an issue. We managed to do all this stuff very, very fast. The real difference, is something I said already. It's that we go from words to concepts, from concepts to compound concepts, and then we do key topic analysis. Another thing that is really different, since we don't deal with words at some level, once we go from words to meanings, the words are gone, we forget them. Now we have meanings, we have concepts. So the control semantic engine is really word neutral and thus language neutral. You can relate 2 documents that are written in different languages because you're relating the meaning underneath. And actually this is one way to test if someone has a semantic engine. if they cannot retrieve text for you in different languages, they are still keyword based because they're indexing the actual words. That's one way to flag that this is not a semantic engine. And our system does get stuff from different languages, and again, we can show it to you. Another comment I want to make: people in semantic technology speak of semantic search, semantic advertising, semantic news filtering, semantic, let's say, X. And they suppose that different engines work in different things. Like there's something for semantic advertising, and there's something for semantic search. Well, not really, because in the end, all of these applications are relating text to text semantically. So they're all doing the same thing. Now, control can be used to match textual content semantically, whether I'm matching an advertisement to a web page, whether I'm matching a query to a document based searching. In the end, we're matching textual sources semantically. So control can be used to do that, which means it can be used to do semantic advertising, semantic news filtering, search. Other things that control does, and again, you can see it if you drop by or you go online. I'll give you the link shortly. Control does text summarization. Once you understand the content, you can easily do a summary of the text. Control does categorization. That's easy for us. It can tell you that this is a document about technology, this is about health. It does metadata extraction. We extract key topics and entity extraction. This was quick. So we really like you to try control. Two ways you can try it. We have a booth 302. We can show you this live. You can also, one of the first services that we put out that uses the control semantic engine, we call it Control News. This is online. It does semantic news filtering for you. We crawl some important news sources, and you basically specify stories that you're interested in tracking in different domains: sports, health, technology, politics, business. And we get you the stuff that is exactly related to your interest. So you can go online and subscribe to it and test it. When you receive articles that we found for you, you can check the summary. You can check the key entities that we found in the document, the key topics. And you can also get related documents to that article from the archive of that day of news. This is where you can go and sign up. It's free. Just sign up, put an email, or sign up using your Facebook account. And we would like to hear from you if you have any feedback. And thank you. That was it.